Now, in chapter number 15, when we were solving questions, we were having all the questions in terms of x. Okay, whatever were my question in chapter number 15, all those questions were in terms of x, and I directly differentiated, and I always get my answers. Okay, but what if, for instance, y is given to me in terms of g, okay, and g is given to me in terms of x. Like y is given to me, for instance, g square plus 3g minus 4. For instance, this is my y given, and g is given to me as x square minus 2x plus 7. And I am telling you guys to find dy over dx. So the problem, y is not in terms of x. So I can't directly get this value. I can't directly get this value because y is not in terms of x. And as I can see, this is the value of g. If I will take it over here and I will plot it, it will become very complicated. So I have to apply something else. So what I am going to apply for this one, I have to find y and x, dy over dx, and for dy over dx, g is common in both. Okay, g is common over here also, like g is connected with y also, and g is connected with x also. So then I use chain rule. What do we mean by chain rule? Chain rule means, see, I have to find dy over dx. So what will I do? I will write dy into dx. First I have written it in this way. For instance, I am writing 1 over here and 1 over here. So everyone is sure, okay, if I will solve this one, this thing will be equals to this. Okay, dy over 1 multiplied by 1 over dx. When I will multiply these two things, it should be equals to this. Okay, or if I'm writing, for instance, b over here and b over here, so this and this can get cancelled, and dy and dx will be equals to this one. Okay, that's our main concept which I'm talking about. Now, for instance, I'm replacing this thing with the common one. Whatever was common with y and x, I'm replacing it with this thing. So what will happen? dg and just a general form, dg and dg can get cancelled. dy over dx will be equals to dy over dx. This is a main concept which I can see, or which I can presume, that product of this one with product of this one will be equals to this thing. Okay, and this is my rate of change by finding out chain rule method. Okay, this is my chain rule method. When will we apply chain rule method? When you have to find differentiation with respect to something, but it is not given in term of that one. For instance, I want dy over dx, but y is not given in term of x. I want dv over dt, but v is not given in term of t. Over there, I am going to apply chain rule. Okay, very simple. Whatever will be your numerator will be the numerator of your first fraction, and whatever will be your denominator will be the denominator of your second fraction. And this will be common. This and this will be same. This and this will be common, and this is how we are going to solve it. So what I always do, I don't tell my student to write it in this form or remember it in this form. I always tell them, let's write it in this way. D It's a symbolic form, beta. Okay, d this over d this. So when I will be writing it in differentiation form or chain rule form, this will be written over here, multiply by this will be written over here. And what will come over here? So differentiation of this with respect to this will be equals to this thing and this thing. These two should be, whatever is numerator over here will be the numerator of first fraction. What will be the denominator of over here will be the denominator of second fraction. And denominator of first fraction and numerator of second fraction should be same. This is how you have to remember your chain rules. In this question, they are telling us that x and y are connected. Okay, they have given us x and y are connected. It means that y is in term of x or x will be in term of y. This will be the thing which they are telling us over here. Okay, now if the rate of change, this is given in the question, if the rate of change of x is 2 units per second, rate of change of x means dx over dt is given to me, and that is given to me as 2 units per second. This is given to me. Okay, find the rate of change of x. Find the rate of change of x. I have to find dy over dt. This I have to find. Okay. When the expression connecting x and y is, okay, now they are telling me the expression by which x and y are connected. There are many expressions. I'm using this one, y equals to 2 over 2x minus 3 whole cube, y equals to 3 over 2x minus 3 bracket close whole cube, and x is given to me as 2. Okay, x is given to me as 2, and they are telling us to find dy over dt when dx over dt is given to me. Now I can see dx over dt, dy over dt. It means dt is similar in both of them. So what will I do? Dy over dt, dx over dt. Dt is same for both. So I can write it, I know that dy over dt multiplied by dt over dx will be equals to dy over dx. So it means if I can have this value, if I will have this value, then I can calculate this one. Now, dx over dt is given to me. So dt over dx will be the reciprocal. So now, if I can get this result, I can get this value. So y equals to 3, 2x minus 3 power minus 3 dy over dx. This will become minus 9, 2x minus 3 minus 4. Minus 3 multiplied by 3 will be minus 9. Power is reduced by 1, and differentiation of inside bracket 2x will become 2 and this will become 0. Simplifying it, dy over dx minus 18 over 2x minus 3. Now, at x equals to 2, I'm solving it over here, beta. At x equals to 2. So when I will plot the values over here, there is a 4 also over here. So this will become dy over dx equals to minus 18 over, plotting 2 over here, 2 2s are 4, 4 minus 3 will be 1, 1 to the power 4 will be this, means my dy over dx is coming minus 18. So I've got my dy over dx now. I have to find this one, and this is already given. So minus 18 dy over dt. This is dt over dx, and this is dx over dt. 1 over 2, 2 shifted over here, minus 36 unit per second is my value of dy over dt. And as the answer is coming in negative, it means this rate is in decreasing form.